Okay, I'm recording now. So, just a little reminder of being respectful, being responsible, and being ready. Um, when we are having these math practice virtual classrooms, it's also important that you participate. You might not know the answer to every question, or you might be confused or whatever, but it's important to at least try. And then there's always the chat feature to where you can send your answers through the chat, or you can also send your questions if you're having problems. All right. Okay, guys, so we have a lot of different topics we're going to cover today. And then we have some more topics that we'll cover next week. And then we'll play like an overall game after all of these things are done. So you guys have been kind of looking at least in sixth grade, you've been looking at patterns. Of course, that was a couple weeks ago, but we're going to look at some of the patterns that you guys came up with as well. And then we're going to kind of switch gears and we're going to go into work with decimals, ordering and comparing, and then estimating with decimals. So that's where we are headed today. So we're going to start off with some work with patterns, and then we're going to solve our own patterns. So here we go.
If we have one table, we can fit 6 chairs at it.
Pretty easy so far. Okay.
If we join 2 tables together and rearrange the chairs, we now have 10 chairs.
So I'm going to pause it for just a second. Is anybody, there we go. Now I'm going to pause it. Is anybody starting to see a pattern emerge?
Yes.
Okay, great. What do you think it is?
I think we're adding 4.
Okay, well, possibly. Let's continue to watch and see if you change your mind.
If we add another table, we now have 14 chairs. Notice the pattern on the chart by looking at the relationship between the number of tables and the number of chairs.
Right, so it looks like we have the number of tables. So, for instance, 3 tables times 4 plus 2. Or, yeah, exactly. Like Clara said, this is pretty easy too. It looks like each time that we add a table, we add 4 chairs.
Because if we didn't connect the tables, then it would probably
It would
just
change.
be adding by 6.
To predict how many chairs are needed for 6 and 10 tables.
All right, so let's start with 6. If we have 6 tables, using that pattern of number of tables times 4 plus 2, how many chairs will we have? Go ahead and type into the chat. Okay, so I'm hearing 24, 26. I'm thinking, just looking at the choices, it's going to be 26.
Good job.
You forgot to add that 2 on the end, Tyler. It's okay. All right, now if we have 10 tables, how many chairs would we need? So number of tables times 4 plus 2. Perfect, Clara. That's right. So 42.
Good job.
All right, so that was a somewhat easy pattern.
Click on the rule that best describes the pattern.
All right, so this is going to get a little more complicated now. So now we just have to actually just look at the table it's already filled out for us and look at the figures. Um, so let's look at the table first. So if we have one figure, we have one triangle. If we have in figure two, figure number two, it looks like we have four triangles. Okay. So then if we move to figure number three, it looks like we jump all the way up to 9. And then we jump to 16, and then we jump to 25. So what we need to do is figure out what's happening between one triangle up to 4, up to 9, up to 16, and then up to 25. So let's look at our choices that we have. Let's see if this one works. If we add 2 to the number of the figure, I don't know about that one. If we multiply the figure number by 2 and then subtract 1, okay, so that's the figure number. And I'm not telling you, I'm just reading you your choices for now. Could we multiply the figure number by itself and come up with the number of triangles? Or could we multiply the figure number by 1 and come up with the number of triangles? I'm going to let you look at these for a minute, and let's pretend this is A, B, C, or D. Maybe on your paper or in your head, that's fine too. I want you to work out these different scenarios and then type into the chat if you think it's A, B, C, or D. So take a minute and go through each choice. And give me just a second. I'm going to snap a picture. Oh, it's not coming up, is it? That's annoying. All right. Okay, so we have a couple people with some guesses, or they've at least worked it out. Right. Screen snap. Okay. All right. Let's see, Clara and Tim. Do you guys have any guesses?
Mm,
Not yet, huh? Well, we had one person who said that they thought it would be choice number C. So let's see if that would work. All right, so he said if we multiply the figure number by itself, we'll end up with the number of triangles. So positioning is a little off here. All right, but okay, so let's just look. If we have one figure and we multiply 1 times 1, then yeah, that one works. Let's multiply figure number by itself. 2 times 2. Does it work there? Yeah, it
yes.
does. 3 times 3. Does it work there? Yeah. So multiplying the figure number by itself, that seems to be the correct answer. So let's go back.
What the?
Using this rule,
And here we
how
go.
many small triangles would be in figure 6?
All right, so if we have figure 6, if we multiply the figure number by itself, what would 6 times 6 be? Yeah, you guys are smart. 30.
36.
You know another way that you could do it?
Oh, here, let me pause it and you can tell
Using
us.
this rule,
Give
how
me
many
just a
small
second.
triangles would be in figure 11?
Go ahead, Clara. Tell us your other thinking.
Um, well, this would make it a lot longer to figure out when you have to like just like this
36.
problem too, when you have to skip a few figures.
Right.
But what you could do is, so you're doing 1 if you go diagonally, and you're going 1, 2, 3, 1, 2, 3, 4, 5. So you're like slowly adding,
Right.
but then that would take longer. So it's
Yeah,
and
it's
put that
it's
away.
easier if you could just figure out the rule right from the get-go, because then you can skip all the way to figure 11, and you don't have to sit there and count and count and count. So
Yeah.
yeah, but I mean that is another way to do it, definitely. All right, so using this rule, how many triangles would be in figure 11? Well, that should be pretty easy. If we're just multiplying the figure number by itself, then what's 11 times 11? Ooh, a little multiplication fact practice. So 11 times 11, one of these choices. All right. Woo! Multiplication facts, guys. 11 times 11 is 121. Okay, we have a new pattern.
Click on the rule that best describes the number of lines needed to draw the triangles in this pattern.
Ooh, so now we're not looking at the number of triangles. Now you have to think a little differently. Now we're looking at the number of triangles versus the number of lines it takes to draw those triangles. So your first one's pretty obvious. One triangle, you got 3 lines. Take a look at the next figure. For 2 triangles, the number of lines that you would need is 5. Okay, so start thinking about a pattern so far. And then if you move to 3 triangles, the number of lines you would need is 7. If you move to 4 triangles, you only need 9 lines.
Literally, like I was the only one with that.
So let's go ahead and read our choices and see which one would make the most sense. Yes, and Tyler typed something into the chat. That's perfect. Which one of these says that choice, Tyler? A, B, C, or D? Would we multiply the number of triangles by 2, then add 1? Does that work?
Yeah, with
It does work.
lines.
Yes.
It does work. Perfect. So we don't have to go any farther. And it was really simple, because we knew that if we had 5, we
How
would have
many
just
lines
added
would Greta
11.
need to draw 20 triangles?
But here's why it's important to find that pattern. Because if we didn't want to make this really, really long list all the way down to 20 and keep adding 2 every time, it was much easier to find a quick pattern by multiplying the number of triangles by 2 and then just adding 1. We could skip to 20 and make it simple and do it quickly. So 2 times 20 plus 1. What do you think? Good, Clara. So 2 times 20 plus 1 is 41.
Well done.
Good job, Tim.
Those guys are freaky.
I know.
All right, so that guy's kind of funny. All right, so that was just a little warm up on patterns. And now what's going to be kind of cool is we're going to look at some of the patterns that our friends came up with,
Ooh, that's gonna be exciting.
and we could try to figure them out. And if you are the author of these patterns, then, maybe you can just give us a hint along the way. All right, so let's get to some of these patterns that you guys came up with. Oh, all right, so here we go. Here's some of the patterns that Clara came up with. Let's just start with this top one. So these are addition patterns. Let's look at pattern A. So we're going from 56 to 75 to 94 to 113. I'm going to give you guys a couple minutes to figure out what addition pattern Clara was coming up with. Hold on, I'm going to get this blank. Just give me just a second. Got to get a blank screen for us. There we go. Ah, so annoying. Am I able to write on? No. All right, so right now you should be working on pattern A while I am messing around with Sketch, trying to get a nice blank paper. It's not working right now. Okay, well. All right, so we went from 56 to 75 to 94 to 113. Anybody want to guess what the next number would be in this pattern? Here, I'm going to get a blank one, and even if I can't take a picture of it, I'll at least be able to write on top of it. Okay, so let me just move that over slightly. All right, so we have 56. Wow, this is wow, there we go. All right. You guys got to forgive me. I haven't used this pen in a long time, and it's writing a lot thicker than it used to, and looks a little funky, but we'll get through it. All right, so we had 56, then we moved to 75. Turn this off, maybe that'll help. 94, and then 113. Okay, so we got some guesses. I'm going to turn this off because that's just not looking good at all. So we think that the next number would be 132. Clara, are they correct?
132, yep.
Okay, so what were you adding each time?
I was adding 19.
You were adding 19 to each one. This next one's really simple. It looks like she's just adding 4 each time, so we'll skip that one. Let's go down. Oh, this one looks tough. Wow, this is a multiplication pattern. So she's moving from 64 all the way up to 512, then up to 4,096, and then clear up to 32,768. Okay, I'm going to give you a hint. In order to find what you need to multiply 64 by to end up with 512, you would turn this into a division problem. So you would write 512 underneath the division house. 64 is on the outside of the house.
Put it over here.
So I'm going to give you a couple minutes to work on that division problem. I'm going to turn that off. And you can see what the pattern might be. I'm going to try one more time. Okay, so hopefully, well, Tyler, I don't know yet. Have you done the division problem? Have you done 512 divided by 64? All right, maybe it'll let me write where I'm supposed to now. 512 divided by 64. Wow, that is looking bad. All right. This is the problem that you should be working on?
8.
All right, so you got to think to yourself about how many groups of 64 will fit into 512, because we know that 64 will not fit into 51, so you have to think of it as this. I'm hearing Tyler guess 8, so let's see. All right, 8 times 4, 32, carry the 3. 8 times 6 is 42. Just kidding, 48. Plus 3. Do we have it?
Mm-hmm.
I think so. All right.
I
Stupid.
have all these like equations that I've been working on for those patterns. I can't
Yeah.
even find my equation to it.
Perfect. All right, so that's exactly right. All we would have to do is multiply each one of these numbers that you see by 8 each time. Okay. All right, guys, so that one was a little bit more difficult. Hi, Sienna. We're just working on some patterns right now, and we are solving some that Clara came up with for us. Let's skip down and try this first division pattern. So we are working with 68, and then we move to 34, then we move to 17, and then we move to 8.5. So we need to figure out, what do we divide 68 by?
No.
Actually, that's pretty easy. In order to get 34, and then what do we divide 34 by in order to end up with 17, and so forth. So I'll give you a moment to try a couple different options. That's right, Tyler. So if you cut something in half, Tyler just typed into the chat, if you cut something in half, you are dividing by 2 each time. So that would be 68 divided by 2 is 34, 34 divided by 2 is 17, and so forth. Perfect. All right, let's skip down to operations. So let's look at, oh, this one might be a little easy, but we'll try it anyway. Our first pattern, we move from 12 to 24. But then we go back down to 16, and then 18. You may need a calculator. Well, Tyler, would -8 work each time? I don't know.
That's part of it.
Yeah, that's part of it. So
Yeah.
there's 2 steps involved in this particular pattern.
I wanted to use multiplication, subtraction, addition, and division, but then that would be way too long of a pattern, so I didn't do that. So.
That would be really complicated. Yes, Sienna just sent it to me right now. The pattern is multiply by 2 and then subtract 8. And then multiply by 2 and then subtract 8. Perfect. All right, guys. How are we feeling about patterns? Are they fun?
Mm-hmm.
Yeah? Are we feeling, and none of you have your webcams on, so just type into a chat a happy face or sad face, depending on how you feel about them.
It's
You're,
actually multiply by 2, subtract 8, and then add 2.
oh, oh, we missed part of that step then. Oops.
Did I do too many numbers or?
No, I think you were fine. I lost it though, so don't worry. I don't have it
Oh,
pulled up
okay.
anymore. All right, guys. So we're going to switch our brains over a little bit, and we're going to jump into kind of a new topic. We're going to talk about decimals. We're going to start pretty easy this week with comparing and ordering decimals, and then just doing some practice problems with them. And then next week, we're going to start the multiplication, division, and so forth of decimals. So let's start off kind of easy, not terribly easy, but all right.
Oh.
These people are funny.
Oh, I like Math Life. That's fun.
Okay.
That hurt.
My family wants to start paying more attention to the kinds of food we eat. We're going to look more closely at the nutrition information found on the boxes of cereal, crackers, granola bars, and so on.
That's smart.
That is a great idea, Hank. I think my family should do the same thing. Do you want to go to the grocery store and take a look at the labels on a few different types of food?
Sure, let's go.
Okay, let's go.
We should first check how much fat is in each serving. Then we should choose the item with the least amount of fat per serving.
No kidding.
The cereal bars only have 3.1 grams of fat per serving.
The wheat crackers have 3.72 grams of fat per serving.
The rice cakes have 0.33 grams of fat per serving.
And the bran cereal had 0.5 grams of fat per serving.
Now we have to compare each of these numbers to decide which is the smallest and which is the largest. Then we will know which item has the least amount of fat per serving.
Before we can do that, we have to make sure we know how to compare and order decimal numbers.
That is correct. Okay.
Before we get going, let's review the greater than, less than symbol. We will use this symbol when we're comparing decimal numbers. The symbol has a larger end and a smaller end. When you are comparing two numbers to determine which one is greater, the larger end of the symbol faces the larger number.
It's like an alligator
The
face.
smaller end of the symbol
You knew that.
faces the smaller number. If the numbers were on the opposite sides, then the symbol would turn the opposite way, like this. The larger end of the symbol faces the larger number, and the smaller end of the symbol faces the smaller number.
Wow, that got loud all of a sudden.
We'll start by comparing decimal numbers that have a digit as far as the tens place.
Not terribly hard when you're only working with tenths.
When we compare numbers to figure out which one is greater, we always start with the digits having the greatest place value and move to the right from there. When we compare these two numbers, we start with the digits having the greatest place value. This means we start with the ones or whole numbers. Because 6 is greater than 5, we know that 6.2 is greater than 5.2. We don't have to look any further than the ones place.
Yeah, not complicated there.
Now you can answer some questions using the greater than, less than symbol. Drag the correct symbol between the numbers to make the math sentence true.
All right, guys, so you have those very symbols down there kind of by your space bar and the letter M, and you just have to use shift in order to get it to type the right way. Yes, this is a pretty basic start here, okay? Don't worry, Tyler, it'll get worse or harder. Okay, so most people are telling me to do this one. Perfect. That's easy. Okay.
Drag the correct symbol between the numbers to make the math sentence true.
All right, go ahead and do it again. Okay, yep. Nice. All right. All right, so now we're going to get into the hundreds.
Before we continue, let's explain what a 100 grid is. We will be using this grid to compare decimal numbers. The grid is divided into 100 squares. Each of these squares represents 1 out of 100, or 1/100th. The grid can also be divided into 10 strips of 10 squares. Each of these strips represents 1 out of 10, or 1/10. Let's look at some more numbers. We'll compare 0.8 and 0.3. We can make it easier by using 100 grids to show the numbers.
And those are both
We'll first fill in the 100 grid to represent the number 0.8. The number 0.8 means 8/10, so we can fill in 8 of the 10 strips to show the number.
Okay, let's get a little harder. All right, moving on.
We can also compare decimal numbers that have digits as far as the hundredths place.
There, now it's getting a little more complicated. My kitty.
Let's compare the numbers 0.29 and 0.65. Once again, we'll show these numbers on 100 grids. The first number, 0.29, is also expressed as 29 hundredths.
All right, guys, type into the chat which number is greater. Yep, perfect. 0.65.
That means
Got
we
it.
can fill
We're
in 29 of the one.
Did you skip it?
We have compared decimal numbers that have digits as far as the tenths place and as far as the hundredths place. We can also compare decimal numbers where one number has digits as far as the tenths place and one number that has digits as far as the hundredths place.
This is where people start getting tripped up, is when, yes, when we're looking at things like this. They look at this and they're like, oh, well, there's more more digits here, so it must be bigger, but you have to be careful.
It's divided up a little bit more.
Uh-huh.
Let's compare 0.02, which has a digit as far as the hundredths place, with 0.2, which has a digit as far as the tenths place. Once again, we'll show these numbers on 100 grids.
This visual
The
will
first number,
definitely...
0.02, is also expressed as 2 hundredths. This means we can fill in 2 of the 100 squares on the grid to show this number. 0.2 is also expressed as 2 tenths. That means we can fill in 2 of the 10 strips on the grid to show this number.
Wow, that was weird.
That hurts. I have earphones on, so that
As you
really
can see,
hurts.
2 strips of 10 squares make a total
Sorry.
of 20 squares.
It's
Another
okay.
way of looking at the second number is to add a 0 in the hundredths spot as a placeholder.
Oh, there you go. That makes it much more clear.
This way we are comparing hundredths with hundredths. 2 strips are equal.
Yes.
When I ended up learning this,
We have compared
it was pretty easy. All you do is, hundreds are usually more, but then the tens are really more because they're the farther in the front.
Right. Yeah. Well, and they actually take up, you think of it as that hundredths grid, they take up more space. They take up a bigger chunk. Yes. And even though the hundredths looks like it has more digits, that's where people get tripped up.
several pairs of decimal numbers. We are ready to put a group of decimal numbers in correct order on a number line.
Yes, we are.
An excellent way to do that is to use benchmark numbers. A benchmark number is a number that is familiar and easily recognized.
Oh,
For
yeah.
example, on this number line, we label the first point as 0, the second point as 0.5, and the last point as 1.
10.
These numbers can all be called benchmark numbers.
Well, that would be 1.0. Yep.
The ones I learned were much bigger.
Now that we have established our benchmark numbers, we can look at other numbers to see how they compare to the benchmarks. Let's try placing a few numbers on the number line.
Okay.
We know that 0.43 is slightly less than 0.5, so we can place it on the number line next to the 0.5.
All right, they did that one for us.
Remember, you can add a 0 as a placeholder if it helps you to compare the numbers.
All right.
Now we can place the next number. 0.99 is very close to 1, so it can go right next to the 1 on the number line.
And I think we've
Our
got
next-
this. All right. We got to get to the actual practice part.
It's your turn to put a group of decimal numbers in order from least to greatest on a number line.
All right. So
Drag and drop the decimal numbers onto the number line in order from least to greatest.
let's just start
When
with
you're ready.
this one. Where would I go? You could just tell me if I'm hot or cold.
Cold,
Cold.
Cold.
Cold, 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 cold,
cold.
cold. There.
All right.
I'm tired.
Okay, now look carefully at this number. That's 3 hundredths. Hot or cold?
Cold,
Cold.
cold,
Cold.
cold,
You're on fire.
cold, hot.
Yeah.
This one? Okay. All right. Hot or cold?
Wait, cold, cold, hot.
Hot. Yep. That's the only logical place that one would go. All right.
Hot.
And then, of course, that would be the only other place. Okay.
Click the check button.
All right. So this is a
Drag and
little...
drop the decimal
little
numbers
harder?
onto the number line in order from least to greatest.
Okay, I'm going to start
When you're
with
ready.
the hardest one here. This is 9 hundredths. Hot or cold, Tyler?
Cold, freezing,
Cold.
cold,
Cold. Cold.
Cold.
There.
cold.
You want it to be here? Are you sure, Tyler?
No.
Hot.
Yes. Look how small that number is, Tyler. That's practically 0. So we got to be clear down there. See how easy it is to mix up these these numbers? They look very similar, but they mean something totally different.
Hot.
What? Okay, this one's super easy. 1.99.
Hot rocks.
Yeah.
No, that doesn't make sense to me.
And then the other two. Uh-oh, I might be messing this up.
Mm.
Should I reverse those?
Yes.
Yeah, I think so.
Dur, dur, dur.
Okay. All right. Very good. And I actually know that we got those all correct. And so let's move on to some sixth grade practice. And here we go. Well, as soon as it comes up, that is. All right, so now we are going to be finding the value of h. And so, of course, it's going to be a decimal number like we were just looking at. This gets a little bit more complicated because you need to look at how many units there are on this number line. We start at 0, we end at 1. So you need to tell me what the value of h might be. So I'm going to let you go ahead and get a stab at it. Okay, good, Sienna. Perfect, actually. Good, Clara. So I'm going to give you a hint. This would be 0.1 or 1/10. Okay. 0.2, 0.3, perfect, 0.9. Okay. Now let's go a little faster. All right, so again, what would the value of A be in this situation? Looks like we've divided it up into tenths again.
Yes.
So we're looking at tenths. So Tyler V, what would the value of A be?
The value of A would be...
Good, everybody in the chat. We're working with tenths, so this is 1/10, 2/10, and then
0.
3/10, right? 0.3. Perfect.
Ow, my finger.
All right. Okay, now this should be getting really fast. The value of P would be 1/10, 0.1. Very good, Tim. All right, the value of T, they have not changed our units yet, so we're still working with tenths. All right.
It's a race.
Okay, so this is, look carefully, 0.1.
Wait, no.
Perfect. All right, so that was actually pretty easy. So let's get to a slightly harder skill. You guys are fast. Of course, you already knew that.
I don't
You
know
guys
that
want
when
to
I was
move
like
into
in
adding
third
and
grade.
subtracting decimals? I think you
What?
guys are ready for it. Let's do it. Let's move into
Yeah,
Oh, yeah.
this is too easy.
All right, let's move up then. Let's move up to some 7th grade. Why not? I'm game.
Yes. My third grade math was like 6th grade math.
Okay. All right. You're bad. You want to go to 8th grade? Let's do it. I'm fine.
Of
Fine.
course, you're past all of them.
Yes, I have. But let's find something that has to do with decimals. Oh, it doesn't look like 8th grade deals with decimals anymore.
What?
Percents are kind of like decimals.
That's
Yeah.
true. Where did you see percents? Did I go too fast?
The bottom.
Oh, there we go. All right, cool. Let's do it. How would we write 40% as a decimal?
0.4.
There you go. Very good. 0.4. Perfect. So you guys this is great to know that I'm going to have to go higher and higher with this particular 9 a.m. group. That's awesome, though. That's great. All right. How would I write 0.9 as a percent? 90, and then, oh, I have to put the percent sign. Cool. All right. Oh, now we're getting a little bit more difficult. How do I write 7/20ths as a percentage?
You would write it as...
Here, let me try to pull up this ugly sketchboard that...
oh no. Oh. I'm just kidding.
All right. This is not a blank document. I don't know why they're saying that's blank. Ah. All right. Well, I'll have to just write kind of small.
Nope.
There we go. All right.
Yeah.
7/20ths. All right. This thing is not my friend today. Sorry. And we're working with percentages. Everything is out of 100. So a really simple way to look at this, guys, is what would I do to 20 in order to end up with 100? I would multiply it by 5. So what do I do to the bottom? I do to the top, and 7 times 5, we all know, would be 35.
35.
Perfect. So that would be our percent. All right, this is good to know, my 9 a.m. group. I think I'm going
So
to
I was
start.
right.
I'm going to start planning maybe some algebra, some pre-algebra for you guys. You guys are on top of it. I do want to make sure that we multiply and divide decimals though next week, because that actually is pretty hard. So, all right, my 9 a.m. group, you are free to go. And if you have any other questions or anything, you can go ahead and email me. And if not, I will see you on Monday.
I do gotta say one thing.
Okay, go ahead.
It's in the chat.
Okay, I'm going to 0.55. All right, Tyler, we will challenge you next week. I'll come with some calculus, and we'll get you all taken care of. How about that?
All right.
All
I'll
right.
see you later.
All right, bye, Tyler.
No, but seriously, my school is way too advanced. I learned cursive in kindergarten.
Oh wow. Yeah,
Yeah.
well, that's abnormal. So,
Yes, it is. See ya.
bye. And Clara,
Bye.
just to answer your question before you go, Clara, the STAR test basically gives me the data on what you did well on and what you did not do well on. So when
Have
you
you
put those,
gotten ours?
I did. Yes, I already emailed them to your parents and to you. So
Oh, yeah.
yeah, so you already have it. All right, Clara, you have a good day. Okay.
Okay.
All right.
Bye.
Bye. Hi there, Grace Elizabeth.
Hi.
Hi. So we're gonna start in just a couple minutes, because you're the not. He could get his go-to meeting to work. All right. So let's just kind of review our virtual classroom rules. We have the 3 R's. We're always respectful to each other. We're responsible, and we're ready. So that means listening to others, making sure that if we're using the chat feature, that we're keeping the chat on topic, and that we're in a quiet room by ourselves.
The headphones don't work in it. I don't know why.
What, Grace Elizabeth?
Nothing.
Oh, okay. Yeah, Claire, I do see that Tristan is trying to get in. So, and Tyler Scoffel, it seems like he sometimes shows up a little late. So that's not a problem. But anyway, so we're going to go ahead and get started today. We have a couple more things to practice. And then next week, at the end of all of these topics, we'll have a game that we'll play. But let's go ahead and jump right in with our first topic, and that is factors and prime and composite numbers. So this will be a little, sorry, I hate that intro. It's so loud. So this will be a little introduction, and then we have practice problems along the way that we'll be doing. So, all right.
Our soccer team has a meeting this weekend, and we are in charge of setting up the chairs. How can we arrange them into even rows? We have 12 players on the team. You can help us by choosing an array for the chairs. Be sure to try every possible array so we have a chance to see them all before we make our decision.
All right, so we have 12 chairs, and we've got to arrange them.
How can we arrange 12 chairs for a soccer team meeting? Please try every possible array.
Okay, so I will show you our different choices. So we can have one row with 12 chairs. Okay. So hopefully you're seeing the equation across the bottom, and what they are doing is filling in all the factors. Okay. The factors of 12, that's what we're finding right now.
You have chosen all of the possible arrays. I think that because the room is so small, the best choice for us is 3 rows of 4 chairs. I agree. There are sure a lot of ways for us to arrange the chairs. And I just realized something. To come up with those different ways of arranging the chairs, we use all of the factors of 12. 1, 2, 3, 4, 6, and 12.
Okay. All right, so those are the factors.
Let's take a look at factors. A factor is any number that is multiplied by another number to get a product.
All right, so we know in a multiplication problem, the answer is called the product. So a factor are any numbers that you can multiply together in order to get a product. And in this case, we're working with the product 12.
In our example with the chairs, we discovered all of the numbers that can be multiplied by each other to get a product of 12. To determine the factors of a given number, you can always start with 1 and the number itself. For example, to find the factors of 4, you can start with 1 and 4. You know that 1 is the smallest factor of 4 and 4 is the largest factor of 4. To find the other factors, you can go in order of the numbers in between 1 and 4 and see if there are any other numbers that can be multiplied together to get a product of 4.
All right. So Deanjane, welcome. I'm going to go ahead and mute you so there's no background noise.
Can 2 be multiplied by another number to get a product of 4? Click on the circle next to your choice of answer.
All right, guys. Can we multiply 2 by any number and end up with a product or answer of 4? What do you think? Go ahead and type into the chat. Yes, no, and maybe what I would multiply 2 by. Okay. So it's kind of a trick question. Let's see. So I'm getting a couple of people saying yes and a couple saying no. Well, let's just click on yes. That is correct. You can multiply 2 by itself in order to get 4. So it was kind of a trick question, Claire. But yes, you can multiply 2 by itself. So 2 is a factor.
We can add 2 to our list of the factors of 4. Can 3 be multiplied by another number to get a product of 4? Click the circle next to your choice of answer.
Okay, now this should be easy. Is there anything I can multiply by 3 and then end up with an answer of 4? Okay. So what would I multiply by 3 to end up with 4? I don't know. I don't think there is anything, guys. Hi, Tristan.
Hello?
Hi.
I can't believe this is working.
Oh, you're good. All right, guys, so that is correct. 3 cannot be multiplied by any other number in order to get 4.
When we list the factors of a number, we put the numbers in order from least to greatest and put commas in between the numbers.
Okay. All right. So let's do a little practice here with another number. We just were using 12. Let's list the factors of 14. All right.
Excuse me, what are we doing?
Right now we are working with factors, and then we're going to move into prime and composite numbers, and then we're going to move into multiples. So we just went over what factors were, and I think you're probably okay there, Tristan.
Yeah.
Okay. All right, so we're going to list the factors of 14. I like to make something called a factor tree. Let me move this to the center. Maybe not. Woo, that came out big, but that's okay. My pen is weird today. So when I'm listing the factors, I make something called a factor tree, and I start with the very easy ones. I put 14 at the end, and then I put 1 on the other end. Okay. Oh my gosh, guys, I'm sorry. My pad is not like registering at the same place that I'm writing. It's really weird. Okay, so now let's start with 2. Is there anything I would multiply by 2 in order to get 14?
7?
That's right. So I would list, and this is just annoying because it's not going to look pretty. Give me a second here. All right, 2. Oh my gosh. Wow. That is not cool. I'm going to have to find something else to write on. Let me see if I could pull up just a blank Word document. Bear with me for a second. I'm going to see if I can find something else to write on because my sketch pad is not registering where I put the pen down, and it's really annoying me. So if I can't use my pen, I'm going to be sad. All right, so it's taking forever, but let's just do a blank document, see if that will. Where is my blank document? There it is. Okay. Will it let me write? Give me a second. Oh, I don't think there's any pen action. So let me just type. That'll work. All right, so at the top I have my 14. Let's make that super big. We're going to put it in the center. Underneath it is where I do my factor tree, and I always start with the easy ones, 1 and the number itself. So 1 times 14, of course, is 14. We were just talking about, are there any other numbers that you can multiply by another number and end up with the product of 14? And there are. So let's do 2 times 7. Okay. Could we multiply 3 by anything in order to end up with 14? No, definitely not. What about 4 times anything? Oh my goodness, we have somebody with a lot of background noise, so I'm going to go ahead and just
Yeah, sorry, that's me. I'll mute myself.
Oh, okay.
It's because I'm in a hospital right now.
Are you really? Oh, I'm sorry. Okay. So we got you muted, Tristan, so there won't be any background noise. That's great. So the only factors of 14 are 1, 2, 7, and 14, because there is nothing I can multiply 3 times in order to end up with 14. That's just because 3 times 4 is 12, 3 times 5 is 15, so that won't work. 4 times 3 again is 12. 4 times 4 is 16. So therefore, that is not a factor of 14. And then we know that 5, obviously 5 times 2 is 10. So that's not a factor of 14. And 5 times 3, we already jump up to the answer of 15. So 5 is also not a factor of 14. So here's what our list would look like. Type a happy face into the chat if that makes sense for you. That's right, Grace Elizabeth. 2 times 7 is 14. So what we just did is we listed the only factors of 14. Cool. And in the movie, they had shown us the factors of 12. All right, so now we're going to move into something a little bit more complicated, prime and composite numbers.
As you know, the factors of 7 will be between 1 and 7. Click all the factors of 7.
All right, so now remember what a factor is. A factor is a number that you can multiply together in order to end up with the answer of 7. So I could obviously start with my easy 1 times 7. Okay. Is there anything I can multiply 2 by in order to end up with 7? You guys can give me a thumbs up or type a no or a yes into the chat. Thumbs up, thumbs down. Okay, so Claire, give me a thumbs up. Is there any, or a thumbs down? Is there another number that we can multiply by 2 in order to end up with 7? No, right? Because 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, so therefore that is not a factor. What about 3? 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, so is that a factor of 7? No. 4, 4 times 1 is 4, 4 times 2 is 8. Nope, so already we've already passed up 7. So therefore, that is the only two factors of 7, is the number 1 and itself.
Notice that the number 7 has only two factors, 1 and 7. A number with only two factors is a prime number. The two factors are always 1 and the number itself.
Okay, so that is what a prime number is called. A prime number only has two factors, 1 and itself.
Click all the factors of 9.
All right, guys, so this is a little different. Let's start easy, of course. So 1 times 9, perfect. 2 times anything will give you an answer of 9? I don't think so. But 3 times 3 is 9, right? So that's definitely a factor of 12. I mean, a factor of 9. Sorry, factor of 9. What about 4? What do you guys think? Is 4 a factor of 9? I'm seeing no, and that is correct. What about 5? Is 5 a factor of 9? No. 6? No. 7 and 8, obviously not. No. So these are the only factors of 9, 1, 3, and 9.
Notice that the number 9 has three factors, 1, 3, and 9. A number with 3 or more factors is a composite number.
Okay. And they're calling it composite. I've always called it composite. Tomato, tomato. Just depends on how you want to say it. But yes, so just remember that a composite, or however she said it, number has 3 or more factors.
The number 1 is neither prime nor composite. It only has one factor.
Okay, so number 1 is our exception to both rules.
The number 0 is neither prime nor composite.
Okay, and 0 is also an exception to those rules. All right.
Here's your chance to sort a group of numbers into primes and composites. You'll send the numbers into the appropriate columns by clicking on the arrows.
All right, so let's start with 16. What do you guys think? Type into the chat. You could just put a P or a C if you want. Is it a prime number or a composite number? Now let's just remember, prime numbers only have 1 and itself as a factor. Composite numbers have 3 or more factors. That is correct. It is composite. Look at all the factors of 16. 2 times 8, 4 times 4, and of course 1 times 16. Perfect. All right, let's go a little faster. 24, prime or composite? So C or P? Good, very nice. Composite, because it has, look at all the factors of 24. It has a ton of different things you can multiply together in order to end up with 24. Perfect. 2, prime or composite? Ooh, that's kind of a trick question. Okay, remember, a prime number only has 1 and the number itself. And that's right, the only factors of 2 are 1 times 2. That's it. Ooh, 19, prime or composite? I don't know, 1 times 19. But what else can I multiply together to get 19? Well, let's see. Most people said that it's composite. Let's see what the computer says. No, try again. The only two things you can multiply together are 1 times 19, right? Because 2 times 9 is 18, and that's not right. So 19 has to be prime. All right, guys, look at 5. Prime or composite? One times 5 is 5. Is there anything else I can multiply together? I don't think so. Okay. All right, let's go a little faster. We've got harder numbers. 33, prime or composite? So P or C? Good, Tristan. That's right. The factors of 33 are 1, 3, 11, and 33 because we can multiply 3 times 11 and get 33. Good. What about 8, prime or composite? Okay, I'm getting some people saying prime. Let's see. I don't think so. We have more than 2 factors for 8. We have 2 and 4 that you can multiply together, so that makes it composite. Good. What about 7, prime or composite? That was their very first example, so this one should be easy. So 1 times 7. Yep, there's nothing else I can multiply in order to get 7, so it has to be prime. Okay, 50 is pretty easy. Prime or composite? Yeah, there's lots of things you can multiply together to get 50, definitely. And 9, prime or composite? Again, it's composite. We already did that one. Lots of factors for 9. Good. All right, let's switch gears a little bit, although it's very related, and move into multiples.
I'm glad we were able to use factors to help us decide how to arrange chairs for our soccer team meeting. I wonder if there is an easy way for us to figure out which days our team will have a game.
I know a great way to figure that out. We can use multiples. Our soccer team has a game every 5 days this month. If we start counting on the first day of the month, on which days will we have games?
All right, let's check it out.
If the team plays a game every 5th day, it will play on these days.
So guess what we just
All
found?
of the days that we have soccer games are multiples of 5.
Multiples are pretty easy.
A multiple of a number can be found by multiplying it by any number other than 0. Now it's your turn to find multiples of a number. Our soccer team has a practice every 7 days this month. If we start counting from the first day of the month, on which days will we have a practice?
All right,
Click on the days the team will practice.
All right, so now we're looking for multiples of 7. I'm going to do the first one for you. All right. Perfect, Tyler. He's already typed it into the chat. Go ahead, guys. Type in the multiples of 7. Perfect. Easy.
Great work.
By finding multiples of 7, we have determined that our team has a practice on the 7th, 14th, 21st, and 28th of this month.
For every 8 goals our team scores, our coach will take us out for an ice cream cone. He will take us a maximum of 6 times. To find out how many goals we need to score to get all 6 ice cream cones, we can use a hundreds chart to help us find multiples of 8. Click on the multiples of 8 to find out how many goals we need to get all 6 ice cream cones. Remember to start with the number 8.
All right, so this gets a little bit more complicated. Here we go. We'll start with 8. All right, guys, I want you to start listening into the chat. What is my next multiple of 8? Type it in. Okay. What's my next multiple of 8?
28.
Go fast. Think fast. All right, so I have 8 times 1, 8 times 2, 8 times 3, 8 times 4. What's 8 times 5? 8 times 5 is not 30. 8 times 5 is 40. 8 times 6. Multiplication, guys, go fast. 8 times 6. 48. 8 times 7. Woo! Some multiplication facts for you. Sorry. Okay. Although this is a multiple of 8, you were only asked to find all the way up to 48. Oh, okay. Because, yeah, we've already got our 6 ice cream cones. So there we go. But yes, the next one would be 56, and then we'd go to 64, and so forth.
Great work! You found the multiples of 8 up to and including 48. They are 8, 16, 24, 32.
Yeah, we know. All right. Factors versus multiples.
Here's a way to remember the difference between factors and multiples. Let's look at number 6 as an example. The factors of 6 are 1, 2, 3, and 6. The greatest factor of a number is always the number itself. The multiples of 6 are 6, 12, 18, 24, 30, and so on.
Here's another
The least
way.
multiple of a number.
Here's another way to look at it. Look at this word, multiples. It's really close to multiply. So think of multiples as multiplying. 1 times 6, 2 times 6, 3 times 6. So multiplying. That's how I look at it, at least.
Is always the number itself.
If you can remember this, you should have no problem knowing the difference between factors and multiples of a number.
Which you'd be surprised how many times people get confused. What is a factor versus a multiple? But you'll never get confused ever again, right, guys? Okay. All right.
It's time to wrap things up with a few questions to check your understanding of factors, multiples, primes, and composites. Which of the following are multiples of 4? Click on the circle next to your choice of answer.
Okay, so let's just pretend this is A, B, C, and then D. So which one of them is showing me the multiples of 4? So think of multiplying. Right. 4 times 1, 4 times 2, 4 times 3. You guys got it. Okay.
Which of the following are the factors of 24?
All right.
Click on the circle next to your choice of answer.
Okay, factors of 24. A, B, C, or D? Ooh, be careful. Factors, remember, I always think of my factor tree. 24 is the biggest factor of itself, and then 1 is the smallest factor of itself. So here would be my factor tree of 24. Okay, right.
Which of the following groups is made entirely of prime numbers? Click on the circle next to your choice of answer.
Ooh, prime numbers. Remember what a prime number was. It only has 2 factors, 1 and itself. So take a look closely. You don't have to go as fast now. Be careful, Tristan. I think that 1 is not considered a prime or composite number. So 1 is like an exception. So look again. I think the best answer would be A. All right, those are prime numbers. So again, just remember that 0 and 1 are not considered prime or composite, okay? Those are like exceptions.
Which of the following groups is made entirely of composite numbers? Click on the circle next to your choice of answer.
Okay, remember composite numbers have several factors. Good job, Deanjane. I I think Dianjane has given us a very emphatic D. Good job. So all of those numbers have more than one fact, or more than one and itself as a factor. Now, play.
We sure were able to figure out a lot of things using factors and multiples.
Woohoo!
We planned our soccer team meeting, our practices, and how often we get to go for ice cream.
And we learned the difference between prime numbers and composite numbers too.
I can't stand it how they say composite. It's composite. All right, I'm done with those two chicks. All right. Okay, guys, type into the chat or give me a thumbs up. How are you feeling about factors, prime, and composite numbers? Pretty easy? Happy? Happy face? Sad face? Tianjane feels amazing. I'm glad that she feels amazing about it. All right. Okay, good. All right, so then we're going to move into, we're going to kind of switch gears a little bit. I'm going to let you guys vote. Do you guys want to look at some multiplication patterns and multiplication and division fact families? Or do you want to move into patterns? So I want you guys to type into the chat and we'll just take a vote because I don't care. We have time for one or the other. Okay, so I'm seeing. Okay, patterns it is. All right, so this is going to get a little harder. I'm just going to warn you. But I think you'll be fine. Dun, 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 dun. Oh my. I lied. This first example is pretty easy. Then it's going to get hard.
If we have one table, we can fit 6 chairs at it.
Beep, 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 beep.
If we join 2 tables together and rearrange the chairs, we now have 10 chairs.
All right.
If we add another table, we now have 14 chairs. Notice the pattern on the chart by looking at the relationship between the number of tables and the number of chairs.
Okay, so this is the most important thing to keep in mind here, that there is a pattern for the number of tables. Take your number of tables. So for instance, let's just start off easy. 1 times 4 plus 2. So 1 times 4 is 4 plus 2 is 6. And then you can go all the way down the line. Now that seems really, really easy, especially if I was just going to jump to 4 tables, right? Because then we'd have 4 times 4 is 16 plus 2 is 18. But what if I wanted to get crazy and I wanted like 20 tables? Well, it's important to know this pattern so that you can find that quickly. Or somebody's going to step on it.
Use the rule we have developed to predict how many chairs are needed for 6 and 10 tables.
All right, so let's start with 6. So here's our rule. Number of tables, 6, times 4 plus 2. So 6 times 4 plus 2, type it into the chat. Good, Tyler. Yes, you can make sure, try to send me a private message. It makes it so nobody else can see what your answer is. So just to review, the pattern is number of tables, 6 times 4 plus 2. So good job, Tristan. 6 times 4, everybody, is 24 plus 2 is 26.
Good job.
Good job. All right, now we're going to jump up to 10 tables. So number of tables, 10 times 4 plus 2. I told you it was a little harder. Not for Tyler. Good job. Not for DeAnjane. Yay. 6 times 4. I'm sorry. 10 times 4 is 40. Plus 2. 42.
Good job.
All right.
Click on the rule that best describes the pattern.
Okay, so now it's a little bit more complicated here. We have to go through all of these different choices that they give us. So let's just look at the figure. We have figure number 1, figure number 2, figure number 3, figure number 4, and figure number 5. Well, in figure number 1, there's 1 triangle. In figure number 2, there's 4 triangles. In figure number 3, there's 9 triangles. So what we need to do is figure out what in the world this pattern is. We're moving from 1 to 4 to 9 to 16 to 25. And then we need to figure out what this is going to help us with, what the figure number helps us with. Let's look at the choices. What if we added 2 to the figure number? So let's go up here. 1 plus 2. No, that doesn't work. 2 plus 2, well, that would work there. 3 plus 2, nope, that won't work. So A is incorrect. Let's look at B. Multiply the figure number by 2 and then subtract 1. All right. 1 times 2 is 2, and then subtract 1 is 1. Okay. 2 times 2 is 4, and then subtract 1 is 3. Oh, nope, so that's not going to work. So B is not going to work. I want you guys by yourself to figure out between choice C and between choice D, which one will work. Okay, so I got one person who thinks it's D. Multiply the figure number by 1, so 1 times 1. What about this one? 2 times 1? That's not going to work. What about multiplying the figure number by itself? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So our best answer, everybody, would be C.
Using this rule, how many small triangles would be in figure 6?
All right. So what is basically 6 times 6? A, B, C, or D? Very good, Grace. 6 times 6 is 36.
Using this rule, how many small triangles would be in figure 11?
All right. What's 11 times 11? Be careful, Tyler. Think about your multiplication facts. 11 times 11 is 121. You got to look at the choices, Tyler. Yep, I got it, Claire. Good job.
Click on the rule that best describes the number of lines needed to draw the triangles in this pattern.
All right, so now we're looking at number of lines. It's a little more complicated. So we have one triangle, and obviously that's easy. There are 3 lines in one triangle. But when we move to 2 triangles, we end up with only 5 lines. When we move to 3 triangles, we move up to 7 lines. Well, it would be really simple if I just wanted to put 5 triangles, and then I would add 2, and it's 11, and then just so on and so forth. That would be easy, but what if I made it difficult and I said I wanted 20 triangles? Well, that's why we have to figure out what the pattern is. So let's look. Multiply the number of triangles by 2, then add 1. 1 times 2 and plus 1 is 3. 2 times 2 is 4, plus 1 is 5. Ooh, I'm liking choice A so far. 3 times 2 is 6, plus 1 is 7. Okay, I think it's choice A, guys. Do you agree? Yes, cool. So now we're going to try.
How many lines would Greta need to draw 20 triangles?
Okay, so that's why I wanted to figure out that pattern. Because now we're not going to move to an easy 5 triangles. We're moving all the way up to 20. So we have to multiply the number of triangles, 20 triangles, times 2 plus 1. So what is 20 times 2?
20.
40. Plus 1 is 41. Yay! All right, that was pretty funny. All right, so my 945 group, you did an excellent job today. If you have a chance later, you can go back and look at some of the lessons and the practice problems that I laid out here for multiplication problems and division problems. But if not, then we can definitely do those next week as well. I will see you guys all on Monday. So have a fantastic day in my 945 group. Say goodbye to everyone. Bye. All right. Okay, so today we are going to be, Lucas should be joining us, and Hudson will be here, I'm sure. We have Jaden and Adam and Emma, and hopefully Micah will join us as well. All right, welcome. Let's go ahead and get started. So remember that we are going to be respectful and be responsible and be ready. So for math, that usually means that you're going to have like a pencil and paper beside you so that if there is a problem that you have to write down, you don't have to run somewhere and get it. Okay? All right. So Jaden, let's just remember that part of being responsible means that you're going to keep the chat on topic, and that if you have your camera on like you do now, that you are, not being distracting, not like showing us funny things or anything. Okay? All right. Here we go. We are going to do a little problem or a little practice with subtraction with regrouping. And then we're going to look at inverse operations. So some of those subtraction problems, we will do the inverse operations. And then we're going to move into prime and composite numbers and then just go on from there. All right, so here we go. So this is kind of dry. I'm not going to lie to you, but we will make it more fun afterward. This video is not my favorite.
Lucas is here.
Hi, Lucas.
How do you subtract by regrouping? Well, let's take a look at a 2-digit subtraction problem. How about 45 minus 18? Now let's take a closer look at the number 45. 45 contains 4 tens and 5 ones. And we can show that with base 10 blocks. The blue bars represent 4 tens. The green squares represent the ones. So there are 4 tens and 5 ones. The number 18 has 1 10 and 8 ones. If you look only at the ones in each number, you'll see that 18 has more ones than the number 45. So there aren't enough ones in 45 to take 8 away from them. So we have to do something called regrouping. When we regroup, we take a 10 and rewrite it as ones. And we get a new picture or a new way to represent the number 45. This picture shows 3 tens and 15 ones. I took one of the tens and broke it down into 10 ones. So the number 45 can be written as 4 tens, which is 40, plus 5 ones. And it can also be written as 3 tens, which is 30, plus 15 ones. These are 3 equal ways of writing the number 45. But writing the number 45 this way, as 3 tens and 15 ones, will make it easier to do this subtraction problem. So let's clear the board a bit and do our subtraction problem. And we can start by rewriting it. 45 minus 18. So right now the number 45 looks like this picture. 4 tens and 5 ones. We want to rewrite it so it looks like this picture. 3 tens and 15 ones. So we're going to regroup one of the tens. So we're taking 1 10 away. So let's cross out the 4 and we'll write the number 3 above it. That shows that we now have 3 tens. The 10 that we are going to regroup is going to become 10 ones. And we're going to add it to the 5 ones we already have. So that will give us 15 ones. So we can cross out the 5.
All right, so you guys are probably wondering what in the world, she's snapping pictures and blah, blah, blah. I'm going to go ahead and stop this lady because we are way too smart for this and we can go faster. So basically all that we have done is we have borrowed from the 4 and we've turned it into a 3. And so therefore, of course, our 5 will now become 15. And my pen, I'm just warning you guys, my pen is not like the area I write is kind of not where I am writing on my board, so it's kind of all over the place. All right, so 15 minus 8 is, everyone? Fifteen minus 8 would be 7, right? And then 3 minus 1 is
7.
yes, and 3 minus 1 is 2. So my answer to that problem would be 27. Who can tell me how to check my work? If I wasn't
Do
sure.
addition. 27 plus 18.
Perfect. That's called the inverse operation. So if I worked out my problem, 27 plus 18, what should my answer be if I was correct? My answer would be 45, right? That would be how I would check my work. So let's just see. Let's see if I did it correctly. What's 7 plus 8, everyone? 15. You know that.
Yep.
So then I'd carry my 1. Now, everyone, what's 1 plus 2 plus 1?
4. 3.
Perfect. 1 plus 2 plus 1 is, oh, I don't know. I'm moving it around now. Sorry. 4. So did I get my answer correct?
Yes.
Yes, we did. All right. So let me clear this screen. Delete. Go away. I'm going to pull on some harder practice problems now because I think that was pretty easy. I'm going to pull that onto my screen. Maybe. There it is. It's coming up. Can everyone see that?
Yes.
Subtract numbers of perfect. And I actually did not mean to do that particular skill, so give me just 1 second to click on the one that I wanted. Here we go. All right, so I want you guys to start working on this problem. Write it down, please, and then we're going to check our work. 4,588 minus 3,381. Okay. Picture. All right, so now I'm going to be able to write on it, hopefully. All right, 4,588 minus 3,381. All right, so pretty easy so far. 8 minus 1, 7. Good, Adam. What's 8 minus 8? 0. 5 minus 3. You guys can just say it out loud. What's 5 minus 3?
2.
2. And 4 minus 3?
1.
1. So my answer is 1,207. Lucas, tell me how I would check my work.
You would multiply.
No, think of what is the opposite of subtraction, which is what we just did, a subtraction problem. Yes, the opposite of subtraction is addition. So we would add 1,207 plus 3,381. And what should we come up with if we were correct? We should come up with 4,588. So let's just take a look. Oh, my pen is all over the place. 1,207. All right, I'm just going to tell you right now, we are correct. My pen is driving me crazy. All right, 1,000. Should we do one more?
Yes.
Let's do one more. Okay. 5,170 minus 142. Go for it. Okay, so when you get an answer, go ahead and start typing it into the chat. And Lucas, I would like you, as soon as you get this answer, I want you to do the inverse operation and check our work.
Okay.
So maybe we're learning some vocabulary today as well. Inverse means the opposite. So the opposite of subtraction is addition. The opposite of multiplication is division. Okay. So definitely not a race. Jaden, check your work. Just logically thinking 5,170 minus 142 is going to be much smaller than the number you just typed in. All right, so most people are typing 5,000 and 28. as our answer. Let's check. Yay! We got it. All right.
Yeah. Yeah. Woo.
Should we do one more, or are we ready to go on to something else?
It's up to you guys.
Let's do one more and then we'll move on. Okay? So let's just make sure. 4,549 minus 518. Okay. Good, Jaden. Good. Okay, so I'm getting most people saying 4,031. So again, if you did not think that you were correct, oh gosh, typing into these boxes is harder than it looks. If you didn't think you were correct, what would you do to check your work?
Do inverse operation.
Mm-hmm. So if you did not think you were correct, you would go ahead and add 4,031 to 500 and whatever, and see if you came up with that big
518.
That's right. And see if you came up with that big top number. Did you guys know that that inverse operation stuff works with multiplication and division as well? Did you know that?
No.
Yeah, well let's take a look at a couple multiplication problems and I'll show you. Give me a second. Multiplication patterns, that's pretty easy. Let's see here. That one might be hard to start out. Let's see. No, that's not what I want either. We could do this one. Okay. Let me just show you what inverse multiplication or inverse operations will do for multiplication. First things first, I'm going to try really hard to get my screen to let me write on it and not look so bad. So give me a second. Blank, and actually maybe it'll work better if I just do it like this. So our problem, and you can work this out with me as I'm writing it, okay, was 59 times 11. Okay, so you guys can kind of just follow my steps. So we know that we're going to start here with this 1, and 1 times 9 is 9. 1 times 5 is 5. Easy enough. Sorry, it's not lining up, but it's not me, it's the pin. Put my 0 as my placeholder. And then I do the next number, which would be 1 times 9, again, is 9. Oh, stupid pen. Ah. All right. And 1 times 5, again, would be 5. Sorry, that's extremely sloppy. I'm going to find something better to write on next week, I promise. 9 plus 0 is 9. 5 plus 9 is 14. Carry my 1. 1 plus 5 is 6. So my answer is 649. Now, I know that that is correct. But if I didn't trust myself and I wanted to check, guess what I could do? I could turn this into a division problem to check my work. I could put 649 underneath the division house, and I could put 11 on the outside of the house. And when I worked out that division problem, guess what I would get? 59. Sorry, that took me forever to write that down. But so just keep that in mind, guys, that multiplication and division are called inverse operations, and addition and subtraction are inverse operations, and it's a really good way to check your work. Are there any questions on that? No, not for now? Okay. I'm going to take us back to our agenda, and we're going to move into factors, prime, and composite numbers. This is a really good basis for all multiplication and division problems that we'll get into. You got to know your factors and multiples. Okay, here we go.
Our soccer team has a meeting this weekend, and we are in charge of setting up the chairs. How can we arrange them into even rows?
We have 12 players on the team. You can help us by choosing an array for the chairs. Be sure to try every possible array so we have a chance to see them all before we make our decision.
Okay, so we are going to check out all these different chairs.
How can we arrange 12 chairs for a soccer team meeting? Please try every possible array.
Here's one option, 12 times 1. Here's another option, 1 times 12. Here's another option, 2 times 6, or obviously 6 times 2. These are all the factors. These are called factors of 12. 3 times 4, or 4 times 3. Okay. Oh, whoops, I have to do all of them, or it won't let me go on. Okay.
You have chosen all of the possible arrays.
I think that because the room is so small, the best choice for us is 3 rows of 4 chairs.
I agree. There are sure a lot of ways for us to arrange the chairs. And I just realized something. To come up with those different ways of arranging the chairs, we use all of the factors of 12.
Okay.
1, 2, 3, 4, 6, and 12.
Let's take a look at factors. A factor is any number that is multiplied by another number to get a product. In our example with the chairs, we discovered all of the numbers that can be multiplied by each other to get a product of 12.
Okay.
To determine the factors of a given number, you can always start with 1 and the number itself. For example, to find the factors of 4, you can start with 1 and 4. You know that 1 is the smallest factor of 4 and 4 is the largest factor of 4. To find the other factors, you can go in order of the numbers in between 1 and 4 and see if there are any other numbers that can be multiplied together to get a product of 4.
All right. What do you guys think? Can I multiply any numbers by 2 in order to end up with a product of 4? Yes, you can. 2 times 2, right? Is there anything I can multiply 3 by? No.
Can 2 be multiplied by another number to get a product of 4? Click on the circle next to your choice of answer.
Yes, because 2 times 2.
We can add 2 to our list of the factors of 4. Can 3 be multiplied by another number to get a product of 4? Click the circle next to your choice of answer.
Yeah, what do you guys think?
Um,
Can I multiply 3 times something and end up with an answer of 4?
no.
No, so it's not a factor of 4.
When we list the factors of a number, we put the numbers in order from least to greatest and put commas in between the numbers.
All right. So I'm going to show you another example. We'll work with a couple more numbers with factors. Oh, I just already had the answer there. Okay, so here's 14. Here's what I like to do first. I like to start with 1 times 14. to me, those are easy. 1 times 14. I started at the very lowest and the very highest end. Now, let's move inward. What comes after 1? 2. Can I multiply 2 by anything and end up with an answer of 14? What do you guys think?
Nah.
Yes.
Yes. 2 times what?
2
times 7, right?
Yeah.
All right, so far we have these factors of 14. Now what about 3? Can I multiply 3 times 2? That would be 6. No, that's not 14. What about 3 times 3? That's 9. That's not 14. 3 times 5? That's 15. So that 3 is not a factor of 14.
It is 1 off.
Yes. So what do you guys think? Are there any other factors of 14? Type a yes or a no into the chat. That's correct, Jaden. There are no other factors of 14. I have them all listed here. Let's try another number. Let's try 21. Okay? Sadly, no. So I like to start with, like I said, 1 times 21. I like to start at the ends, like the very lowest and the very highest. So 1 times 21 is obviously 21. Now let's oops, did not mean to do that. Let's fill in the numbers in the center. Okay, so what comes after 1?
2.
2. Can I multiply 2 by any number and end up with an answer of 21? 2 times 2 is 4. 2 times 5 is 10. No, 2 times 10 is 20. So no, 2 is not a factor of 21. What about 3? Can I multiply 3 times any number to get 21? So go through 3's in your head. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 3 times 7, what's 3 times 7? Type it into the chat, guys. What's 3 times 7? 21. 3 times 7 is 21. So 3 and 7 are definitely factors of 21. Are there any other numbers that I can multiply together to get 21? Well, let's just look. 4. 4 times 5 is 20, so nope, that won't work. What about 5? 5 times 4 is 20. 5 times 5 is 25, so nope, 5 won't work. What about 6? 6 times 3 is 18. 6 times 4 is 24, so nope, that won't work. So right away, I know that I have all of my factors of 21. Give me a happy face into the chat if this is making sense. These are called factors. Okay. All right. Lucas with a very, I called you Nucus. Lucas with a very long nose, yes. All right. Well, let's move into prime and composite numbers.
As you know, the factors of 7 will be between 1 and 7. Click all the factors of 7.
Okay, so let's start at the obvious ones. 1 times 7. What about any of these other numbers in between? Can I multiply any of those together and end up with an answer of 7? Type into the chat, yes or no. Good, Jaden. Okay, so I don't think that there's anything else I could multiply together to end up with an answer of 7. Because 2 times 2 is 4, 2 times 3 is 6, 4 times 2 is 8. So nothing else except 1 times 7 will give me an answer of 7.
Notice that the number 7 has only two factors, 1 and 7. A number with only two factors is a prime number. The two factors are always 1 and the number itself.
Okay, so that is called a prime number.
Click all the factors of 9.
Okay, so we'll start easy. 1 times 9. What other numbers can I multiply together to end up with an answer of 9? So type into the chat, what else can I multiply together to end up with an answer of 9? You guys should be coming up with 3 times 3, right? Nothing else will multiply together and come up with an answer of 9.
Notice that the number 9 has three factors, 1, 3, and 9. A number with 3 or more factors is a composite number. The number 1 is neither prime nor composite. It only has one factor.
Yep, so 1 does not count, basically. It's neither prime. I call it composite. Yeah.
The number 0 is neither prime nor composite.
Composite, tomato, tomato. All right, so we're going to look at some of these now and sort them.
Here's your chance to sort a group of numbers into primes and composites. You'll send the numbers into the appropriate columns by clicking on the arrows.
All right, let's look at number 3. Is it prime or composite? You could type a P or a C into the chat. Okay, so most people are saying C. But, guys, it only has 2 factors, 1 and itself. So it has to be prime. The only thing I can multiply to get an answer of 3 is 1 times 3. That's it. Nothing else. 15, prime or composite? 1 times 15? But what about 3 times 5? It has more factors, so here you go. It has to be composite. 99. What do you guys think? 99, prime or composite? Good, Adam. I think it has to be composite because you have 1 times 99 and then you have 11 times 9. Oh, and 3 times 33. Look at all the factors of 99. What about the number 73? Ooh, that's tricky. Well, we have 1 times 73. Is there anything else that we can multiply together to get an answer of 73? I don't know. I don't think so. Just 1 times 73. So it has to be prime. Okay, 64. That's pretty easy. 1 times 64, and then we also have 8 times 8. So we know right away that it has to be composite. Oh, and we have 2 times 16. It has a ton of different factors. Let's do some more. 18, prime or composite? Think hard, Adam, because we have 1 times 18, but there might be more. 3 times 6, for instance? 2 times 9? Okay, so it has to be composite. There are more than just a 1 and itself. What about 6? Prime or composite? Definitely composite. Look at all the factors of 6. What about 47? Definitely prime, because that's all we can do is 1 times 47. Ooh, 35. 35, I'm just going to tell you, it has a lot of factors. You have 1 times 35. You have 5 times 7. So what does it have to be? It has to be composite. Good. 85. Okay, most people are saying composite, and you are correct, because 5 times 17, and then, of course, 1 times 85. All right, give me a... You guys got this. A happy face into the chat if you think you understand the difference between prime and composite. All right. Some of us might need a little more practice, and that's totally fine, because on our agenda, I have this linked, and you can go right back to it and do it over. You can look at it again. Not a problem. Multiples.
I'm glad we were able to use factors to help us decide how to arrange the chairs for our soccer team meeting. I wonder if there is an easy way for us to figure out which days our team will have a game.
I know a great way to figure that out. We can use multiples. Our soccer team has a game every 5 days this month. If we start counting on the first day of the month, on which days will we have games? If the team plays a game every 5th day, it will play on these days.
Easy. Multiples of 5.
All of the days that we have soccer games are multiples of 5. A multiple of a number can be found by multiplying it by any number other than 0. Now it's your turn to find multiples of a number. Our soccer team has a practice every 7 days this month. If we start counting from the first day of the month, on which days will we have a practice? Click on the days the team will practice.
All right, so I'll start you off. 7, and then what?
14.
Okay, then what? 7 times 1, 7 times 2, 7 times 3.
21.
7 times
And
4.
28.
Perfect.
Great work.
By finding multiples of 7, we have determined that our team has a practice on the 7th, 14th, 21st, and 28th of this month.
For every 8 goals our team scores, our coach will take us out for an ice cream cone. He will take us a maximum of 6 times. To find out how many goals we need to score to get all 6 ice cream cones, we can use a hundreds chart to help us find multiples of 8. Click on the multiples of 8 to find out how many goals we need to get all 6 ice cream cones. Remember to start with the number 8.
All right, so yes, 8. Then what?
18.
Oh, 8 times 2 is 16.
Right.
8 times 3? 8 times 3, anyone?
24.
Good. 8 times 4?
32.
Yay. 8 times 5?
44.
8 times 5?
40.
Yep. 8 times 6?
48.
Yep, you'd be adding 8, right?
Oh, yeah.
Great work! You found the multiples of 8 up to and including 48. They are 8, 16, 24, 32, 40, and 48. We'll have to score a lot of goals if we want to go for ice cream 6 times.
All right.
Here's a way to remember the difference between factors and multiples. Let's look at number 6 as an example. The factors of 6 are 1, 2, 3, and 6. The greatest factor of a number is always the number itself.
Okay.
The multiples of 6 are 6, 12, 18, 24, 30, and so on. The least multiple of a number is always the number itself.
If you can remember this, you should have no problem knowing the difference between factors and multiples of a number.
All right. I also look at it, the word multiples is really close to multiply. So you're multiplying 6 times 1, 6 times 2. So multiplying. And then factors, I think of that factor tree where I can draw the line. I put a 6 at the top, and then I would draw, let me just show you again. Here's my example with 14. 14 at the top, and I would draw a line to the 1 and a line to the 14, and that's my factor tree. And then I would draw a line to 2 and a line to 7. Okay?
It's time to wrap things up with a few questions to check your understanding of factors, multiples, primes, and composites. Which of the following are multiples of 4? Click on the circle next to your choice of answer.
Okay, so Jaden, maybe you can turn off your webcam for us because you're a little crazy right now. Multiples of 4. So think multiply. 4 times 1, 4 times 2, 4 times 3. Think of this as answer A, B, C, or D. Which one do you think is the best choice? Multiples of 4. So 4 times 1, 4 times 2, 4 times 3, 4 times 4. Okay, so multiples of 4. Remember, we have to start with 4. So we can't start with a 2 or a 1. Definitely can't start with any A, B, or D. We have to start with 4. Okay.
Which of the following are the factors of 24? Click on the circle next to your choice of answer.
All right, factors of 24. This time around, when we're looking at factors, we always start with the 1 times the number itself, so 1 times 24. So the only option would be answer C, factors.
Which of the following groups is made entirely of prime numbers? Click on the circle next to your choice of answer.
Okay, remember, prime numbers only have a 1 and itself for a factor. I don't know, Jaden. Look at that 9. I think 9 has more factors than 1 times 9. And remember, the number 1 is neither prime nor composite, Jaden. So it can't be A, it can't be B. Oh, I don't think it's D, Jaden, or anybody who's looking at D, because 24 has several factors. The only choice here would be C, because all of these numbers only have 2 factors, 1 and itself. Okay.
Which of the following groups is made entirely of composite numbers? Click on the circle next to your choice of answer.
All right, so composite numbers have several factors. Which one of these choices has several factors for every single option? Good, Lucas. Right away, I can eliminate choice C because 0 and 1 are neither prime nor composite. The only one.
I think I know.
Go ahead, Adam.
I think it's B.
It is.
99, 33.
Yeah. Great job.
No, let's see. We sure were able to figure out a lot of things using factors and multiples. We planned our soccer team meeting, our practices, and how often we get to go for ice cream.
And we learned the difference between prime numbers and composite numbers too.
Right.
You can watch this episode again, or you could choose another episode on a different.
Definitely not going to watch that again. All right, so going back to our agenda, if you would like to move ahead, you can go on to your multiplication basics and multiplication patterns, or we can save it for next week. You do have the agenda shared with you in your email if you do have time for that. If not, you guys all did a great job today. Are there any questions?
No.
Okay. Well, it was so great, and I will see you all on Monday. How does that sound?
See you Monday.
All right. Bye, guys. Have a great day.
Bye.
Bye.
Bye. See you on Monday.
Okay.